All right, welcome, ladies and gentlemen. Sorry, I don't know if my brain has been going a little bit. It's probably because I also have the Super Bowl open up in a chat, so I can just kind of follow along with the score. And but I will try to hopefully get this out for you. See that the San Francisco 49ers are currently up 20-10 over the Chiefs. So I am following along with the game, and but I am focused on doing this live stream because one of the things I really want to do is just make sure that I can be available for you guys every week on a live stream, being consistent here at the 9 o'clock hour on Sunday Eastern Standard Time. And I also know that many of you don't care about the Super Bowl or you have other things you got to be doing. So therefore, but this live stream is going to be here for you guys. Or obviously, if you are still kind of watching the game and you maybe just want to get the replay, that's cool as well. So let's go and take a look at what we're going to cover tonight. And then maybe we'll kind of see, obviously, as you guys add into the chat, we'll, kind of going from there. And thank you very much, Go 49ers, from myself again, giving a super chat. I actually didn't pay myself, I swear. But that's somebody else that has an account for Brian McLogan that loves to give me a super chat. So I very much thank you. I appreciate it. And yeah, actually, it's funny. Back in the day, the 49ers were my team. For no reason. I think I just liked Jerry Rice and like Steve Young. That was just kind of my idols growing up. And so I really liked that team. And then so I've always kind of rooting for them. And I don't really have a dog in the fight for this game, but I'm really just kind of hoping for a good game. Just because I enjoy watching like a good football game going from there. So what we're going to cover tonight anyways is trig functions, just a kind of explanation of our trigonometric functions, how to evaluate the sine of 180 degrees on the unit circle, what is the difference between sine -1 like there or parentheses sine of x raised to the -1. Then we have a rationalize the denominator as the problem's written like that. We have eliminating the parameter as well as graphing it. And then we have a distance between the 2 points, 2, 1/2 and q -1, 1. And then last but not least, we have identify the x and y intercepts, then graph. And I know some of you guys have also been adding in some questions on my community post. Some of the questions, guys, I'm just able to do, or some of them I understand them. As far as like what you're asking or what you want me to cover. And some of them I don't know what you actually want me to cover or what your actual question is. So just make sure when you guys are posting your questions on that community chat. And if you are new to my channel or to my live streams, I go live every week on Sunday at 9 p.m. But also I like to take questions that I have students submit to me on my community post. So obviously, as being a subscriber, you'll get notified when I make a nice little community post. And then you can just respond to that post with your questions. And, typically I am going to try to do questions or at least respond to them on the live streams that I can fairly move through them rather quickly, as well as they don't take me too much prep work to obviously get into. So that's why I stay away from word problems or other just problems that I just haven't taught in, a while. And I might just need a little bit too much time to kind of like prepare and just make sure I'm doing it correctly, or maybe explaining it in the most beneficial and like efficient way. And sometimes just problems I just, if I feel I don't want to add them to the live stream, then I'll let you know as well. But anyways, I love having you guys submit your questions. And then also, I know you guys will be adding in some questions as well on the stream. Capture topmost. Okay. So therefore we will cover them as well. So thank you so much, guys. And let's go ahead and get started into the open Q&A. So the first one is just trig functions. And one of the things that I wanted to add about this was when you're doing the trig functions, okay, one of the things when I first taught this, I don't know why I'm having trouble speaking, but when I first taught this, I looked at this and a lot of students, really didn't understand. They had been exposed to the 6 trigonometric functions, in geometry class, but they didn't really understand them. And actually, when maybe it happens a couple of years ago, I remember I first went through the trig functions and I didn't really understand them. Like I knew what they were, I knew how to apply them, but I didn't really know what they were all about. So, let's just say we have a triangle, right? It's a right triangle. We know that's 90 degrees. And then we have some angle, and we're going to use the Greek symbol here, theta, today. It could be X, it could be Y. Now, obviously, we are very familiar with, looking at a triangle. Same triangle here, but just looking at the sides of the triangle, where A and B were the legs of the triangle and C was the hypotenuse. And we created that relationship, right, which was the Pythagorean theorem. Now, so that was a nice little relationship that came out of right triangles. But another relationship, or another way that we looked at comparing things, was like, how do these side lengths compare of this triangle? For instance, like we have A, B, and C, right? Now we know from the Pythagorean relationship that a squared plus b squared is equal to c squared, right? And that c is always going to be larger than a and b. But if we want to look at this relationship based on an angle, one thing we could say is like, based on this angle, how big is b compared to c? Or we could say, how big is the opposite side of this triangle from theta compared to the hypotenuse? And that is what we call the sine, right? So really, all the trigonometric functions is a comparison. They're really just comparing how big is this one side to the hypotenuse. And the same thing can be said, for cosine. Cosine of theta is just the comparison here of this side, which we call the adjacent side, to the hypotenuse. And then last but not least here, we can have tangent of theta, which is a comparison of the opposite over the adjacent, which would be b over a in this case. Now, again, the last thing I just want to cover is, these are comparisons. These comparisons, though, are based on where the angle is, like what the function is. Like this reads sine of theta, cosine of theta, tangent of theta. So they are dependent on which angle you're talking about, because if I was going to talk about alpha in this case, and I say, what is the sine of alpha? It's not going to be b over c, because the opposite side, which we refer to in sine, is going to be directly across from the triangle. So sine of alpha is going to be a over c. All right, and cosine of alpha is going to be b over c. And then the tangent of alpha is going to be a over b. Okay, so therefore you can kind of see like that relationship. But again, it's a comparison. That's all we have for trigonometric relationships, is they're just a comparison of sides of a triangle. How big is one side compared to another side? And then obviously we could also go through the reciprocal functions, and that's basically those relationships flipped, okay? But hopefully that at least gives you an idea of what the trig functions are, and so you can kind of like make sense of it a little bit more. So that's where it's a nice little segue here into sine of 180 degrees, because once we get into angles that are larger than 90 degrees, it doesn't really make sense to be talking, or at least larger than 180. It doesn't make sense to talk about them as far as being a triangle, because we can't create a triangle that has more than one angle if one angle is already 180 degrees. So that's why we come up with the unit circle. And I'm not going to go through a explanation here of the whole unit circle. But what I am going to do is just kind of explain that in this first quadrant, here, how about we do it this way? I'll do the triangle one more time. I'll just hold it. So there we go. Okay. So when you're, when we're working for the unit circle here in the first quadrant, like basically we have our special right triangles, if you recall. Okay, those are going to be making up that first quadrant. And basically all we do is that gives us these coordinate points, right? Now, again, this has nothing really to do with the sine of 180 degrees, but the important thing I want you to do is these are your three special right triangles, the 45, 45, 90 triangle right in the middle, the 30, 60, 90, and the 60, 30, 90, which is just kind of rotated, same triangle. Now, the thing that they all have in common is a hypotenuse of 1. So that's how we got those coordinate points there of the special right of the unit circle. Now, the important thing, though, is on this unit circle, what we recognize is when we're dealing like with opposite over hypotenuse, right? Whatever the opposite side is over the hypotenuse, what was important is the opposite side always represented the y coordinates, okay? And the hypotenuse is always 1. So that's why when we're dealing with a point on the unit circle, and actually, you know what? I'm just going to go through this. Let's just, I'm just getting into like explanation mode, so I'm just going to roll with this. Because if anybody needs any help with trigonometry, this might be a decent review of what some things you need to know, or at least this connection. Because I think a lot of students, and actually even my students, if any of them are watching, it's a good review because, you know, we talk about trig at the beginning of our trigonometry unit, and then we go to the unit circle and we kind of forget about triangles, or at least that relationship of the triangles in the unit circle. And then what happens is we go back to triangles and students get confused again. So I'm not going to go through where these points came from. These are going to be from your special right triangles. But the important thing that I want to bring up with you is we come up with a new relationship here. When the hypotenuse is 1, we can now say that the sine of theta is going to be your y coordinate of your xy coordinate. Okay, and the cosine of theta is going to represent the x coordinate. And again, it's not that they are x and y, it's the fact that they're still opposite over hypotenuse. It's just the hypotenuse is 1, or adjacent over hypotenuse. It's just the hypotenuse is 1, so therefore we can just leave them as the x and y coordinates. And that typically makes things a little bit easier for us to understand. And it really helps us when we need to evaluate for angles that are larger than, 180 per se, because now we can just look at the coordinate point. So if I know this point is 1, 0, this point 0, 1, then this point over here is going to be negative 1, 0, right? And if we know, a straight angle is 180 degrees, we can say that, all right, so this angle is going to be here. The sine represents the y coordinate. So therefore we can say the sine of 180 degrees is equal to 0. So hopefully that kind of makes sense. I'm not sure if you needed that much of an explanation for an answer I could have given you in less than 3 seconds, but hopefully anybody that benefited or, would benefit from that explanation, hopefully that helped. All right, let's move on to the next one, which is sine inverse of x versus sine of x raised to the negative first power. Now this one's kind of interesting and actually something I haven't really thought about. And I'm just going to kind of roll with my explanation here and we'll just kind of go through it because I can see where the student gets confused. And when we use inverse notation, this does not represent raising sine of x to the negative first power. But I can see how that's confusing because when we do sine squared of x, that is to represent sine of x quantity squared. All right. But sine of this does not equal, so when you do sine inverse of x, that does not equal, that does not equal the sine of x raised to the negative first. All right. So this represents our inverse notation. And so therefore we're dealing with the inverse function and of sine of x. So completely different, whereas here represents the reciprocal. And the reciprocal is not always the inverse. So that's where we're going to be dealing with, because this is going to represent as 1 over sine of x, which we learn later is equal to the cosecant of x. Whereas the sine inverse of x is the inverse function, which is not the same as the cosecant of x. So those are not the same. And this is just you really using our notation. I'm not sure as far as what other oh yeah, well obviously a lot of times to avoid this confusion, this is something we use in pre-calculus. I use this notation a lot, but in calculus we'll typically use arcsine. And I am assuming that is more commonplace, so therefore we're not making this confusion because this is something we use all the time, squared, cubed, but that's not designed for those negative powers because we do not want sine inverse or sine of negative 1. We want to use the inverse function, not to represent the reciprocal. So I think that's probably why using arcsine is more of a popular form to be able to use. All right, let's get into rationalizing the denominator. All right, so to rationalize the denominator, again, a little debate of if we need to rationalize the denominator or what. But again, just one of those skills, practicing with radicals and also to avoid dividing by a radical. So what we're going to simply do here is, first thing, I recognize this can be broken down into 2 square root of 2. So therefore I have, excuse me, 2 square root of 2 divided by 2 square root of 3 minus 2 radical 2. Okay, so here's some things that I could rationalize the denominator from here, but that doesn't look like a lot of fun. So what I'm going to do is I'm going to try to simplify some radicals here as much as possible. And so what I'm going to do first is I'm going to multiply by the square root of 2 over the square root of 2. So by doing that, that's going to give me a 2 times square root of 2 times square root of 2 is 2. Remember, you have to apply distributive property here. All right, so this is going to give me a 2 times the square root of 6. And then this will give me, again, minus 4. Okay? And I guess you could factor out a 2 or divide out a 2, but I'm not sure how that's going to help. So then I have 4 divided by, let's rewrite this, as a negative 4 plus 2 radical 6. And the reason why I just wrote it there, just so you can see what the binomial is with this radical. And now what my goal here is going to be, and I guess I could just divide everything out by, if I multiplied everything by 2, then that could just go ahead and simplify. But let's just kind of keep it from here. Let's go ahead and multiply here by your radical. So what I'll do is I'll multiply by a negative 4 minus a 2 square root of 6. Negative 4 minus a 2 square root of 6, okay? So when I go ahead and multiply that out, now I'm going to go ahead and distribute, and make sure you apply distributive property here. And all right, so distributive property up top, I'm going to have a negative 16 minus an 8 square root of 6. All right, guys, you're getting my attention. Hi, Sailing Cam. I see that you are spamming in the group, so that's not great. So let's try to be helpful to everybody that is paying attention to the thing. Jay, I see that you have a question. I'm not going to be able to get to any other questions, though. So, guys, just allow the chat to happen. I appreciate you guys joining in on the stream. But again, let's not keep on spamming through this. So, hi, Silicon. I appreciate it. Thank you very much for joining in. But let's get through the rest of that. Oh, why is that not doing? There we go. Perfect. Okay. So here we go. Then in the denominator here, now we're just going to apply the difference of 2 squares. So we have negative 4 times negative 4 is a positive 16. And then remember, when you are rationalizing the denominator here, you're going to have you're just squaring these, multiplying these two. So we're going to have a 2 times a negative 2, which is going to be a negative 4. And then we have a square root of 6 times square root of 6, which is going to be a square root of 6 times the square root of 6, which is just going to be 6. Sorry. So it's a negative 4 times 6, which is a negative 24. And again, you can see here why I could definitely make some mistakes. I can't do anything in the numerator. And then 16 minus 8 is going to be a negative 8. And then you can divide that through. So you can divide the negative 8 into both of those terms. And that's going to give you a positive 2 plus a square root of 6. X cannot go into x squared. So where are we talking about? The remainder is actually, what remainder? I'm not doing dividing. I'm not sure what you are talking about, Brian McLogan, which is really weird for me to kind of explain to you. Remainder is actually square root of 22. Oh, is that one of your questions? I'm not sure. I'm not sure if you submitted that or who submitted that as far as on there. But either way, let me know if where there was a mistake, or just be a little bit more detailed. Happy to go over that. But anyways, I will finish up these next couple questions, and then I will check, see if there's any other questions I can go through. I can see that the Super Bowl, just taking a quick little stop, looks like that is now, let's see, why is that not going? Ooh. Computer doesn't like running multiple tabs here. and then also go in live stream. So I guess I'll refresh that. Okay, so I still got 11 more minutes left in the fourth quarter. So we'll finish up here. Yeah, roughly around, answer these questions and kind of see if there's anything else I can do for you guys. All right, let's continue on. So eliminate the parameter. Now, we haven't started talking about this yet in my class, but I'll try to just do my best to understand, if we want to graph this, we're going to graph this, based on like X and Y coordinates with our parameter T. So the easiest way to graph this using what we call the rectangular method is to eliminate the T. And basically we can do that just by choosing one of the equations. Typically, you're going to want to choose the equation with X and then just solve for T. So therefore we could say T is equal to 1/2 X, and then you're just going to plug substitution and plug that into the other equation. So therefore we have Y equals the square root to 1/2 and X. Now, hopefully you remember from our chapter on square roots that we realized we can go ahead and graph that, right? And we could say, all right, that's going to be 1/2. That looks like that is going to be a horizontal compression, right? I believe I'm already kind of forgetting. Or 1/2, that'd be 2. So that'd be a vertical stretch, horizontal compression. So either way, it's going to be impacting the graph horizontally, but you can see the graph, rectangular graph, is going to look something like this. Okay. So then what we need to understand, actually, hold on. So that's a vertical stretch. So that's a horizontal. So this is a horizontal stretch, actually. Sorry, 1/2 horizontal stretch. All right. But that's the rectangular graph. Now, this one's saying, but eliminate the parameter, only graph from 0 to 4. So, this is kind of interesting. So what we can do here is we can say X equals 2T. And then what we can do is just pick some values here for what is X and what is T. And because a lot of times with the parameter, we want to see like that direction it's going. So we're going to do 0, 1, 2, 3, 4. Let's do all of those. Okay. So now what I'm going to do is I'm going to plug 0 into this equation to find, what am I doing? I got to plug those in for T. So what we're going to do is plug in 0, 1, 2, 3, and 4. Now what that's going to do is for each parameter T, that's going to give us the X coordinate. So that's what's nice about parametric equations is we can focus on one variable at a time. So when T is 0, we have X is 0. When T is 1, X is 2. When T is 2, we have X is 4. When T is 3, we have X is 6. And when T is 4, we have X is 8. Okay, so based on our graph here, we can see that we have 1, 2, 3, 4. At 0, 0, we're here. So let's do 1, 2, 3, 4, 5, 6. Oh, wait, that's the X coordinate. Jeez. Forgot I'm doing the X coordinates here. Okay, so we get all the way up to 8 coordinates. So 1, 2, 3, 4, 5, 6, 7, 8. All right, now let's go ahead and do the Y coordinates here. Now Y is going to be a little different because I don't have everything for T, right? I'm not going to take the square root of 3. So what I'm going to do is I'm just going to do 0, 0, sorry, over there. I'm going to do 1, and I'm going to do 4. Okay, because obviously I'm not going to I don't have a calculator with me. But when I go ahead and do this, I get 0. That's going to give me 0. That's going to give me 1, and that's 2. Okay, so let's just look at those 3 points. 0, and 0 for X is 0, and then for Y is 0. So 1, 2, 3, 4. So we have that point, which again, we kind of knew from our rectangular point. And then we go when T is 1. So when T is 1, we have a Y coordinate of 1 and an X coordinate of 1. So again, it's going to be going at 1, 1. But you can see here at 4, we have something interesting. When T is equal to 4, our X is at 8. 1, 2, 3, 4, 5, 6, 7, 8. And our Y is at 2. So you can see how this graph is definitely being horizontally compressed from a regular square root graph, right? Because a regular square root graph would be 1, 2, 3, 4, up 2. Right? It'd be a little bit higher up. So you can see how that's being horizontally stretched. And then if you needed to show directions, we're going from 0 to 4 from there. But that's actually not something that I go through in my class. So I'd like to actually convert that. But hopefully you can kind of see, basically, you can look at, the nice thing about parametric equations is you can look at individual variables for x and y's separately based on your parameter t, which most often is representing time. But then when you eliminate the parameter, you can just look at it as a rectangular equation and understand that not only the shape of the graph, but yeah, just kind of really the shape of the graph as well as the rectangular equation, that relationship between them. All right, last two, distance. Find the distance between 2 points. So for this one has a fraction that doesn't sound too much fun, so I don't want to graph it. I'm just going to go into the distance formula. So I'm just going to say, let that be x1, this be y1. Let this be x2, and let this be y2. All right, so the distance formula is going to be square root of, let's see, x2 minus x1 quantity squared plus y2 minus y1 quantity squared. And again, this comes back from our distance formula, or from that Pythagorean theorem that we talked about at the beginning of the live stream. Which, oh yeah, by the way, all right, we're doing good on time. All right, so let's go ahead and just plug it in and see what we get. So we have -1 minus 2 quantity squared plus y2, which is 1 minus 1/2 quantity squared. Okay, so -1 minus 2, you borrow $1, you owe me $2 more. Or I'm sorry, you borrow $1, you borrow $2 more, so therefore you now owe me $3. And then you have $1, but then you borrow a half, or you give away a half, so therefore that's going to be 1/2 squared, which is equal to 1/4. So let's kind of do this math. All right, so this is going to be 9 plus 1/4. Let's go ahead and let's write this in terms of 4. So that'd be 36 over 9. No, 36 over 4. Right? There's nothing wrong with writing 36 over 4. 36 over 4 is the same thing as 9, right? But the nice thing about 36 over 4 is that it has a denominator of 4. So now I can combine that with my 1/4, which is a 37 over 4, which now I can break up my radical into the numerator and the denominator. And now I can take the square root of 4, which is 37 over 2. And therefore I could rewrite that in front, 1 over the square root of 37. So hopefully I went ahead and got that on. And comment, thank you very much for the super chat. I see that coming through. I really do appreciate that. And Laura McLogan, thank you very much, my love, for a super chat that I missed earlier. I thought something caught my eye, but I was like, I couldn't remember what exactly it was. So I do appreciate that. Thank you very much, even though you're just in the other room, so not too far away. But I thought there was another one that I thought something caught my eye. But again, let's see, that's, no, looks like everything's good. Okay, well, thank you very much, guys, for the super chat. I really do appreciate that, going in through the live streams. So let's get on to the last questions, and then if, where was your name? If you have a question or anything else, I'd love to be able to help you out. Hopefully I can answer it, because I am not the genius and cannot answer all my questions. But yes, Max, I can go over the Pythagorean theorem if you would like from that. Yeah, exactly. But I did kind of talk about what are things. So if you have maybe a question, Max, then I can go through that. Okay, I just do not think you care about that. So, all right. So last question. Let's go ahead and do the identify the x and y intercepts. Then graph x minus 2y equals 6. So the nice thing about this problem is we can actually don't need to convert this to slope-intercept form or do anything else crazy with this. All we need to do here is just take say the x-intercept. X-intercept is when y is equal to 0. And the y-intercept is when x is equal to 0, right? Because if you look at a graph, right, here's the y-axis, there's the x-axis, right? And again, these are just number lines. Or again, like look at it, like here's the number line. The first number line that you learned, like here's 0, 1, 2, 3, 3. And let's do 1, 2, 3, -3, right? That's called the x-axis. And then so all we did for the y-axis is we just took another number line and just did it vertical. But the point that I'm trying to make is when you have a point that's on this y-axis, right, which we call the y-intercept, x is equal to 0, right? And you can see that because we just have that line where x is equal to 0. So the same thing works when we're trying to find the x-intercept. That is when the graph crosses the x-axis. We can see that that's going to be y is equal to 0. So for this problem, all I simply need to do is plug in 0 in for y and then solve for x. And then here, plug 0 in for x, which I didn't do, and then solve for y. Okay, so in this case, I just get x equal to 6. In this case, I get y, All right, -2y is equal to 6. So then you divide by -2, divide by -2, y is equal to a -3. Now again, these are intercepts, right? So therefore, this point is 6, 0, and this point is going to be 0, -3. So the student asked to have this graphed. Well, since we only need 2 points to make a line, we're good to go here. So I can do 1, 2, 3, 4, 5, 6, and then 1, 2, 3. And there you go. All right, guys, that is it for the questions. I'm going to check on the game, and then I will see if I can answer any more of your guys' questions. So, all right, so it looks like it's still 20-10. I'm following along, so I do want to catch the last 5 minutes, but hopefully maybe I can answer some of your guys' questions here. Oh, man. Okay. So when you guys keep on typing in the same thing over and over again, YouTube is picking up on that, and therefore it's blocking it as spam. So I'd highly recommend not typing in the same thing over and over again, because I'm seeing a lot of stuff that's being blocked, and therefore I don't want you to have your questions blocked like that. So just make sure if you have a question, answer it, and a little bit while if you're engaging the chat, then you can obviously go ahead and re-ask the question. But just constantly typing in the same thing over and over is not working out. So all right, let's kind of go through here. Hello, LCM Vlogs. Can you look at my super chat? Brian McLogan. Yes, I can. Brian McLogan, so weird. Let me go and see if I can look at your super chat. Let's see, where else can I find your super chat? I got to get used to a little bit more of this. I mean, I can look at the back. How long did you super chat? I didn't see your super chat from there. But anyways, thank you so much for guys, for those of you that were answering any questions from there, or at least helping each other out. Can you go over graphing pinches? I do not know how to graph those. So I apologize because that's a super chat and I really appreciate it, but I'm not sure what you need me to kind of cover. So maybe if you can give me a little bit more details for that, Mr. Brian McLogan, from there. All right. And he says, I'm sorry, but knowing that you should make feel better, can you help change it? You want to become educated, not indoctrinated. Start research things told climate change. Oh, geez. Okay. All right. Let's see here. Domain and range for inverse functions. That's a good thing. The best thing that I can just really tell you with inverse functions is, if you find the domain of your function, that is the range of your inverse. And the domain of your inverse is the range of your function. I'm not going to cover another example for that because I'm close to being signed out, but that's basically that relationship. If you remember, and actually just kind of quickly, like if I ask you for any equation, like how do you find the inverse of that equation, of that function? You swap the x and the y's, and then you solve for y. So again, if you understand that domain is the set of x values, the range is the set of y values, it makes sense that the domain and ranges are just swapped with a function and its inverse. So my best advice is, again, to you need to find the inverse, right? Or at least know how to find the domain. So you're going to take a function, find the domain, set of all x values. Done, whatever the restriction is, if there is any restrictions. Then from there is you find the inverse. Find the inverse by swapping the x and y's and then solving for y. Use inverse notation. But then you find the domain of that inverse function. Well, the domain of that inverse function is the range of your original function. So hopefully that helps. Max Garcia says, do you know Calculus 4? No, I do not know Calculus 4, or at least I took some version of that when I was in college, but it's been way too long since I did a lot of that in-depth calculus, and I'm not even sure Calculus 5 or what type of calculus that you are just going through, but I took up into Calculus 1, Calculus 2, and then I started branching off into different types of mathematics from there. So all right. Okay, I guess see if there's anything else from you guys. Well, you're very welcome. Kakan said, I aced my exam and my son for introduction to functions. Your videos were very helpful. Well, very good. I'm so happy to be able to help you back. Or be able to help you. Sorry about that. Can you show how to graph a derivative from the graph of the original? It's been a while from there, but again, like just to kind of do a quick, oh no, I'm running out of things. Well, but just remember, like if you have f of x, I'll just kind of do a very, very basic one, right? So the main thing is when we're looking at this, that we have, that's going to be negative there. Okay, so if this is f of x, the point that I'm trying to make here is remember that f inverse of x is just representing, all that does is represent the slope, right? So if we're reading f of x, and now we want to graph f prime of x, all right? So what we're gonna do is we're gonna look at the slope, basically saying when is the slope, when is the graph going up, and when is it going down? All right, so you can see here, the graph is positive. Here, I'm sorry, the slope is positive. Here, you can see the slope is negative, right? From this point to that point, you're going down. And then from here, the slope is going positive. So when we're graphing f inverse of x, I'm getting into my pre-calculus, but we're doing f prime of x, what we're going to do is we recognize, so at this, extrema here, we change from a positive to a negative. And then over here, we change from a negative to a positive. So f prime of x represents the slopes. So at this point over, the slope was positive. That's why f prime of x is in the positive form. It's a positive version of the graph. Between this point to this point, we have a negative slope. So therefore, that's why the graph is going to be in this negative version. And then for any point to the right, it's going to be, again, a positive slope of that red graph. So my blue graph, my f prime of x, is also going to be on the positive version. So that is just a really rough definition or a really rough explanation. It's been a while since I've gone through explaining. Obviously, if I was a little bit more recent with my calculus explanations, I'd probably provide something a little bit better. But unfortunately, just off the cuff, you'll have that to work with. But hopefully that helped out. All right, guys, I am about to go because I do want to see at least the end of the game, how it's going to unfold, because it does look like it's starting to get a little interesting here. But I do really appreciate you guys joining in for my live stream. And again, for those of you that are new or first time at the stream, I do go live every Sunday at 9 p.m. Eastern Standard Time. And you can submit questions. I don't answer all the questions. I am not a math genius, but I try to do my best as long as you can be clear and concise and hopefully maybe provide some examples or just be detailed in what you would like me to help you with. But you can, I always post a community post on my channel on Saturdays, typically in the morning or early afternoon. And then you can just respond to the comments by then. And I pick and choose what I want to handle for the stream on every Sunday. And then again, we go through some work here in the chat. And if I didn't get to any of your questions here on there, make sure you guys could go ahead and just respond to the chat or for community chat for next time, and I'll be happy to get there. So again, guys, have a great evening, and I'll see you next week. Cheers. Oh, yeah. No, that still doesn't work.